Okay, next we're going to talk about the three forms of a linear equation. Okay, right now we're just going to talk about the first one. But there are three ways to write a linear equation. The first way we could write it is called standard form. Okay. Standard form is written like this. Okay. It's in the form a times x, so ax, plus by, b times y, equals c. So ax plus by equals c. Some things to note in this form. A and b are in front of variables, so a and b are coefficients. So a and b are coefficients. So a is in front of the x value, b is going to be in front of the y value. Together, ax and by are your variable terms. Why are they variable terms? Well, they have variables in them. C is a constant, so C won't have a variable on it. Again, we always want it in this form where the variable terms are on the left and the constant is on the right. So the left side is going to be the variable terms, and the right side is going to be the constant. Okay, so ax plus by equals c, that's standard form. There are a couple rules to standard form. The first rule is that a and b both can't be 0. Again, a and b both can't be 0. Okay, again, if a and b were both 0, it'd be 0 times x plus 0 times y. That would just be 0. You'd end up with 0 equals c, 0 equals 0. It wouldn't be a linear equation anymore. Okay. So a and b both can't be 0. Second rule is that a, b, and c have to be integers. So what that means is no fractions, no decimals. They have to be integers, positive or negative whole numbers. The third one is a rule, but it's not always followed. Okay, we're going to try and follow it as much as we can, though. And it's that a should be greater than or equal to 0. Okay, so what that means is that a should be positive. And the last rule is that a, b, and c should have a GCF of 1. Okay, remember what GCF is, the greatest common factor. It should have a greatest common factor of 1. Okay, so they shouldn't share any common factors. So if a, b, and c were all even numbers, you should divide them all by 2. Okay, if they were all multiples of 3, you divide them all by 3. So you want it kind of in its lowest form. So the greatest common factor of 1 means they don't share any other common factors. Okay, so now we're going to run through some examples of putting linear equations into standard form. Okay, so put the following into standard form. And remember, we have to follow these 4 rules. A and b both can't be 0. Again, if they were 0, it would be a linear equation. A, b, and c can't be fractions. They have to be integers. A should be positive, and a, b, and c should have a GCF of 1. Okay. So again, standard form, the form we are looking for. We're trying to get into ax plus by equals c. Alright, so we have 6y equals 12 minus 4x. Our variables should be, all of the variable terms should be on the left side. So, what do we have to move first? Well, we got this 4x term on the right side. That has to be on the left side. So, first thing we should do is to move that 4x term to the left side. Okay, so again, see the same skills we did when we were solving equations and literal equations. We're just moving things around. Okay, so now we got 4x plus 6y equals 12. Okay, that looks like it's an ax plus by equals c form. So make sure it is in that form. Variable terms on the left, constant terms on the right. But does it break any of our rules? And it does. The GCF of this equation, the greatest common factor of a, b, and c, a is 4, b is 6, and c is 12, they have a GCF of 2. Okay. We need to have a GCF of 1. So if you have a GCF of 2, you're going to have to divide each term by 2. And that leaves us with the standard form equation of 2x plus 3y equals 6. And that is in standard form. Now you should get in the habit of being able to identify a, b, and c. So remember, a is the number in front of x, b is the number in front of y, and c is the constant. So in this problem, a is 2, b is 3, and c is 6. Let's move on to the next one. 5/3 y minus x equals 5. Okay, well, first thing I noticed, my variable terms are on the left side, so that's good. The next thing I notice is that there's a fraction. We're not supposed to have fraction coefficients. So what we're going to have to do is we're going to have to clear that fraction. We're going to have to get rid of that fraction. And to do that, we're going to multiply the entire equation by 3. Okay, so same technique we were doing when we were solving equations with fractions. We just got rid of all the fractions. That's what we need to do here. We need to get rid of the fractions. Okay, so when you multiply this entire equation by 3, the fraction part, the bottom of the fraction cancels out with the 3. So it's going to drop down to 5 and give you 5y. But then remember, you're still multiplying everything else by 3 as well. It is just a big distribution problem. So you're going to have to multiply the minus x by 3, leaving you with minus 3x. And multiply the 5 by 3, which leaves you with 15. Okay. This is close to standard form, but it's not quite there yet. Okay, the reason being it's not ax plus by, it's by plus ax. So we're going to have to flip the order of these two. Now remember, it's a commutative property of addition. You can rearrange the terms. But remember, whatever sign is in front of that term has to stay with it. So this is a minus 3x. So that minus 3x, that minus part has to stay with the 3x. So when we rewrite it, it'll be minus 3x. The 5y is positive, so plus 5y equals 15. And we're close, but your a value is negative 3. The a value should be positive. Okay, so we have a negative a value, we need it to be positive. You can multiply the entire equation by negative 1. You could divide the entire equation by negative 1. Or you could simply just flip all the signs. Okay, it's the same thing as multiplying or dividing by negative 1. So instead of negative 3x, I want positive 3x. So I'll just make it positive 3x. But then you have to go through and flip all the other signs. So instead of plus 5y, it'll be minus 5y. Instead of equaling positive 15, it'll equal negative 15. Okay. And then now we're in ax plus by equals c form. There's no GCF. 3, 5, and 15 don't share any common factors. And then identify your a, b, and c values. A is the number in front of x. A is 3. B is the number in front of y. B is negative 5. Remember, the sign stays with its value. And c is the number in front, or no, c is the constant, which is negative 15. Alright, a couple more. This next example, y equals 2x minus 1. This is a different linear equation form, okay, which we're going to do next. But for right now, we want to put it in standard form. So putting this in standard form, again, it's kind of like the first one, where we're going to have to get all the variable parts on one side. So we're going to have to move this 2x from the right side to the left side. And we're going to put it out front because we want the x term first. That's negative 2x plus y equals negative 1. Alright, and then the same issue as the second problem we did. The a value, it's in the correct form, but the a value is less than 1. It's negative. So, if we want to make it positive, we're going to flip all the signs. So we're going to change the minus to a plus, plus to a minus, and then minus 1 to positive 1. So it would be positive 2x minus y equals positive 1. Alright, so that is standard form. Identify what a, b, and c is. A is the number in front of x. A is 2. B is the number in front of y, but there's not a number in front of y. There's a negative sign, though. And there is. It's the same. If there's not a number, if there's not a coefficient, it's implied to be 1. So that's negative 1y. So our b value is negative 1. And then our c value is the constant, which is 1. Alright, and then this last example is a little different. It's x equals 6. Is that a linear equation? It is. It doesn't break any of the rules of a linear equation. The exponent on the variable is 1. There's not exponents being multiplied together. There's no variables in the denominator. So this is a linear equation. It's a special type of linear equation, but it still fits the rules. This is in standard form too. There's no GCF. There's no fractions. There's no, all your variables are on one side. So this is in standard form. Okay. Well, if this is in standard form, what are my a, b, and c values? Okay. Well, a is the number in front of x. Okay, again, there's not a number in front of x, but it's implied to be a 1. It's a 1x. So a is 1. B is the number in front of y. There is no y term here, which means b is 0. And c is the constant. The one on the right side, c is 7. Again, that does still have an a, b, and c value. Now, again, we would never write it like this, but it could be rewritten as 1x plus 0y equals 7. That's standard form. But again, we always write its simplest form, which is just x equals 7, where a is 1, b is 0, c is 7. Alright, so that is standard form of a linear equation. We'll talk about the other two forms in the next couple lessons.